Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Rat Run 1 Year Earlier by Marty Sears. And here are the rules. For the final preliminary free roam trial, the 9 shortlisted rats were placed in a 9 by 9 space, and their movements were observed and recorded. Each of the digits 1 through 9 appear in each row and column. Okay. Observations. Every cell in the grid was visited exactly once. So every cell is going to be visited by some rat at least, or exactly once, not at least once. No rat's path contained any repeated digits. So that means every rat's path is going to have to contain the digits 1 through 9 exactly once each. Interesting. No rat chose to move diagonally at any point. So there is no rat going diagonally. So they all move horizontally or vertically. Every 2 by 2 area was visited by at least 2 rats. So you cannot have this rat say, you cannot have Albie, go in this direction. Because then this 2 by 2 area would only be visited, well, hold on. I'm assuming, yeah, no 2... Oh. No. Yeah, it says no, so every cell in the grid was visited exactly once. So since every cell must be visited exactly once, and no rat's path contains any repeated digits, every single digit must be visited by a rat, and we have the digits 1 through 9, 9 times each. So every rat will go through the path 1 through 9, so you cannot have a repeat. No 2 rats started on the same digit. So that means all the digits that the rats are on currently are different digits. And no 2 rats end on the same digit either. And all black courants and red courants, yes, I'm going to use the incorrect pronunciation, were eaten. But no grapes were eaten here. So that means no rat will go through a grape. All the rats will all go through the black courants and the red courants. Okay. So there must be a path. So no 2 by 2 area again. It was visited by at least 2 rats. So that means Albie could not go something like this, right? Because then this 2 by 2 area, because every cell must be visited by a rat, and there are no repeats in rat's paths. That means no other rat can go on this path here. So that's why this would not work, because this 2 by 2 area would not have 2 rats enter that area or visited by that area. No, again, no 2 rats start on the same digit, no 2 rats end on the same digit. All black courants and red courants were eaten, and no grapes were eaten. If a black courant sits between 2 digits, one is double the other. So, for example, if this were 2, this would have to be 1 or 4 to make sure that those digits are in a 1 to 2 ratio. For red courant, if a red courant sits between 2 digits, one is odd and the other is even. So there's always going to be an odd-even pair here, an odd-even pair here, and an odd-even pair there. And finally, we have grapes, where if a grape sits between 2 digits, they have a difference of at least 5. So, for example, if this were, say, a 3, this would have to be 8 or 9, because the only digits which are 5 or more away from 3 are 8 and 9. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so this is essentially a chaos construction rule set here. Because every cell in the grid must be visited exactly once. Oh, that's another thing. It's every cell is visited exactly once. And no rat's path contains any repeated digits. Well, that means the rat paths have to be essentially each region. So, let's do the region borders here. And every rat that is next to each other must be a different region. We also know for every cell, for every red, currant, and grape, they must be eaten. So these must be on a path. Okay, well, that's helpful. And the grapes are not. So you always have to have a path going through these cells. Maybe I should make it green. The boundaries will be black, but the paths have to be green. Okay. So G then is going to have to go through here. A cannot go here. These are in a 1-2 ratio. So these are going to have to be essentially the same region for both of this and this and this. Because they have to go, every grid is visited exactly once. Every cell in the grid, is visited exactly once. So these are we know are the same region. This we know is the same region. 1, 2, 3, 4, 5, 6, 7, 8, potentially. These are all the same region. So because these are the same region, they have to be 3 unique digits in this set of 3 digits here. So we're guaranteed this has to be 2 or 4, which is in a 1-to-2 ratio with 1, 2, 4, 8 and 1, 2, 4, 8. Same with this. This is 2 or 4 with the digits 1, 2, 4, 8 and 1, 2, 4, 8. No grapes were eaten. Okay. So that means we cannot go through any of these paths, obviously. Hmm. Who can go on this red path here? E could do that. B, I don't think so, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's possible. B could go there. 1, 2, 3, 4, 5, 6, 7, 8, 9. F could go there. This is in a 1-to-2 ratio. This cannot be 5 next to this. Next to the black crappie dots. Let's just do those. They have to be 1, 2, 3, 4, 6, and 8. Because 5, 7, and 9 can never be next to a black Kropke dot because it can never be in a 1 to 2 ratio with another digit. If you have 5, 7, and 9, you get 2.5, 3.5, 4.5. If you double them, you get 10, 14, and 18, none of which are digits. So this is 5 away from each. This can never be 4 here because we don't have a 9 possible there. Hmm. What else do we have? Ah, no 2x2 area was visited by at least... Okay, so every 2x2 area was visited by at least 2 rats. So the G cannot be going this way because then this 2x2 area would be visited only by G. So these are separate regions. So we can either have 1, 2, 3. So who can go into here? Um, we don't know about this. So it could be someone enters here. It could be someone enters there. So this 2x2 area is separated out from this area because we have this whichever rat is going this direction, it cannot enter that one. So who can reach the blue? I can obviously. H cannot. 1, 2, 3, 4, 5, 6. It would cut off I from being a full region. Can F 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? No. So I could be blue. C, G cannot be. C 1, 2, 3, 4, 5, 6, 7, 8, and 9. Technically, yes. So could D. A cannot reach. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Who can reach the corner? I think it's just B and E, right? The upper left corner, I should say. A cannot go this way. Because then this 2x2 area would be all visited only by A. One, two, 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Technically, F could reach the light, whatever is here. And then we have dark, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So G could reach dark. So F could reach F could reach any of the corners, except that this has to be, it can't just be reach the corner. It has to go to the corner and extend, which is obviously why this can't be blue. So F could be any of the corners, can get to any of the corners. B and E can reach light. H can reach red. E could reach red. So could light, actually. Technically. Or, sorry, B. C and D both could reach the... Could C, actually. I don't think so, right? So if... So G can never reach the corner. Or cannot be in blue. But C, how would C reach the dark corner? Can't go here, then here. Even if she goes around this way, so Conquer, or he. Conquer goes this way. D, 1, 2, 1, 2, 3, 4, 5, 6, 7. The problem is D would have to go this way, and how would A go? It would go that way, but then it would be 2 by 2 area would only be visited by Albie. So C, I don't think can ever be dark. I cannot go to red because then H would not have a full region be part of it. So Holly wouldn't be able to make it. B as a number cannot be 5. It'd be 1, 2, 3, or 6, 7, 8, 9. So H either goes this way or this way. If H goes this way, she cannot go around here because then this 2 by 2 area would be all only visited by her. Oh, A could obviously be dark also. A could do something like this. That is possible. That is problematic, though. So what happens? Okay, so A can obviously be part of dark, but if we choose not to be part of dark, some other rat is going to have to eventually end in this cell. So A has to, that means dark would go here, at least. A has to go at least here. So A would be going this route. And the problem then becomes what rat can eventually reach here if A doesn't get there. Assuming A goes this way, right? If A goes this way, C and D can't reach there. F could. Well, could she? So let's see what path A would go on. A would be going here. Dark would have to go something like that. A would have to go along this path because these black currants need to be eaten. She cannot go that way because then that would block this from being connected. So she has to go that way. 1, 2, 3, 4, 5, 6, 7. She cannot go that way. She cannot go this way. So she would have to go that way. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because she can't go this way because then the 2 by 2 area here would just be visited by Albie. Or I guess it's a he. So then here would have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and would not be able to be visited by any rat. So, Albie cannot go this way. Albie has to be part of the dark. So this cannot be dark. This can't be dark. So Albie goes this way. Guaranteed. Then must go this way. And we know there's a boundary here because no 2 by 2 space can be all the same rat. It must be visited by at least 2 rats. So Albie has to go this way. And I think we have the same problem. So Albie can't go this way because then he has to go there. Well, maybe that works. 1, 2, 3, 4, 5, 6, 7, 8, then has to go 9. F can no one. This B still can't reach. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. F can't reach. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So Albie has to continue on going that way, which means Albie goes there. We have boundary here. Boundary here. So one of these rats is going to have to go here. F could now. 1, 2, 3. Finks could. 1, 2, 3, 4, 5, 6, 7, 8, 9. But the problem there. So if F goes, B obviously can't reach. If F goes here to reach this area, the problem is who enters to this cell? If D tries to go there, she's stopped here and can't go anywhere else, right? So that's not going to work. C can't go that way because C would have to go around, but then, okay, so we know the path cannot go this way, obviously, or that way. So you can't reach enter in that path, if that's the case. So if F goes this way, the problem with that is that nobody can reach here because D would have to go here, but then get stopped by F's path here because each cell in the grid is visited exactly once. And then you can't enter here and then exit back out. So F cannot reach this. C can't reach here. This has to be part of the region for D. So D is going to have to go this path. So Dylan is a guy, has to go this way, then has to go here. I guess I should make this medium then. So medium, 1, 2, 3, 4, 5, 6, 7. So this is a boundary here. 6, 7 can either go that way. Cannot go that way, because if it goes that way, that blocks this region. So either this is going to enter, C is going to enter here, or some other rat is going to enter this way. Oh, but that's, well, could enter from there, technically. So we know this has to go this way. Since these three are the same region, or the same rat, we have to have another rat visiting. So that's a boundary. That's going to be a boundary too. Because you can't go here and then go back there. So this is a boundary. D cannot go through there. So that means it must be going through here. Which means, and we know this is a 2-4 pair, have to be here. Guaranteed in this set, because you either have 2, which is in a 1-2 ratio with 1 and 4, or 4 in a 1-2 ratio with 2 and 8. So this can never contain 2 or 4, so this must be, oops, a 3-6 pair, since they are in the same region. That means gray has to continue on to here. And this is the ending point. Oops. For Dylan. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is either going to be B or it's going to be C. We're not sure which. If it's going to be B, that means someone's going to have to end up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's not a rat to start with. 1, 2, 3, 4, 5, 6, 7 is too short. So C has to go this route then. So this is, we'll make her pink. 4, 5, 6, 7. Then it cannot be 8, 9. It could be 8, 9 that way. It has to be this way. Because the problem is, can't go that way. If she goes this way, the only rat that can go in this area would be B. And that would be a 2x2 area. That would be all just B. So, she cannot go that way. She can't go that way. You have the same problem, right? You have a 2x2 area that's all going to be the same rat. So she's going to have to go that way. Conquer, or he. It has to go that way. So we have the path going that way, then here. That means someone's going to have to end here. So this cannot be light. This can't be light. So the only light has to be F. 1, 2, 3, 4, 5, 6, 7, 8, 9. So not red, not dark. Okay. B cannot go this way. Now B has to definitely go this way. So someone's going to have to end up here. It can't be E. So this path has to go that way. Oops. B has to go that way. One, two, three, four, five. So that's going to be the ending. E cannot go there. 1, 2, 3, 4, 5, 6, 7, 8, 9. But the problem is that blocks that way. So this has to be the full H. So it must go this way. Otherwise, it would block this red region from being done. So this is done as a region. Okay. That means this is a 1, 2, 3, 4, 6, 8, 6 tuplet in the red region, which leaves just 5, 7, 9 remaining. In the region, 5, 7, and 9 are odd, so these must be even. So it's no 1, 3 here. This is no 1, 3 here because of the red courants. Okay. I is almost certainly going to be part of this region. Oh yeah, I is the only one that can be now. So I has to be part of this region, which means Ibel must go this way. Because he cannot go that way, because then that 2x2 region is all the same region. Cannot, that's 1, 2, 3, 4, 5, 6, 7. Has to go there, 8 and 9. Because there's no other path to take. So these are all blue. Albi has to go that way. 1, 2, 3, 4, 5, 6, 7, 8. Cannot go that way because that would block this cell from having a region, so it has to go that way. So we have boundary here. G cannot go here. So glitch has to go that way. There's boundary here, boundary here. So this is going to be dark. We're going to make this orange. This is going to have to be some rat, so it's probably E. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. So E has to go, Elba has to go that way. Orange has to go this way. 1, 2, 3, 4. Cannot go 5, 6, 7, 8, and 9 because then this 2x2 area is all orange. So almost certainly has to go this way. And then B is going to have to go that way. 1, 2, 3, 4, 5, 6, 7, 8, and 9. There we go. So these are the regions that the rats are going to. So now we have to figure out what the digits are. Okay. Let us see. Remaining digits in the pink region cannot contain 3, 6, or 2, 4. So we have 1, 5, 7, 8, and 9 remaining. Because we're guaranteed a 2 or 4 here. And this is a 3, 6 pair. Yeah, we don't need the paths anymore, so it just clutters things up. So let's... All the grapes are not eaten. And all the black and red courants are. Okay. So we don't need any of these. Okay. Only one digit from 5, 7, and 9 can be among these cells here. Because we have... So whichever digit that is has to be one of these digits here. But only one of them can be. These 3 specific digits have to be here in the light region. So we have 2, 4, 6, 8, 5, 7, 9. That means 1 and 3 are going to have to be either here or here. So 1 would be with 2 in this region. So that means 1 can be here with 2, or 1 can be here with 2. Or 1 could be... Okay. 1 could be with 2 here. This cannot be... It could be 2. No. In this region, 1 is in a 1-to-2 ratio only with 2. And it has to be in a 1-to-2 ratio because we have 3 sets of digits with black courants between them. So, since 1 can be here, that could be 2. Since 1 could be either of these, this could be 2. But this cannot be 2 here because it doesn't have a corresponding 1 there. This can't be 2 here because there's no corresponding 1 there. Okay. So this could still be 2. So we have 2 digits from 579 here, and then 1 from that is even, 2, 4, 6, or 8. Okay. 6 again can only be with 3. So since either of these could be 3, either of these could be 6. This can't be 6 because that would require a 3 to be there. This can't be 6 because that would require a 3 to be there. Okay. Um. hmm. Hmm. So these 4 digits here must be exactly the same as those 4 digits there. These 3 digits here have to be exactly the same as those 3 digits there. These 3 digits here have to be the same as these 3. Six, 7, 8, 9. Hmm. These 4 match these 4. These 4 match these 4 here. These 6 obviously match these 6 here. Hmm. This cannot be 6 here because of the 3, 6 pair in the row. Remaining digits in row 2. We have 1, 2, 4, 5, 7, 8, 9. Okay. This is the part that's tricky, I feel. I feel like the chaos construction part was pretty straightforward. But this part is a little tricky. It's essentially we're using the irregular region Sudoku to try to limit things, but I don't. First of all, I'm not the best with irregular region Sudoku, so there is that. So this digit has to be one of those 3, and then is one of these 3. Oh, interesting. Okay. Where in row 8, where is H? It obviously can't be the same as G because no starting points are repeated. No 2 rats start in the same digit. Can't be here because it's in the same region. Can't be here because it's not 5, 7, or 9. So H has to be one of these digits here. That's interesting. So let's make letters then. Maybe this will be helpful. H has to be one of these 3. H has to be one of these 5 because that's G. Cannot be 5, 7, or 9 there. So where is H in... cannot be here, cannot be here. H in column 2 is one of these three. That's not too helpful. H could be here, cannot be here. So H has to be one of these cells here in row 7. I is obviously one of these cells here. So I cannot be here. I is one of these cells here. Obviously can't be F. Can't be here. Where is I in the light cells? It must be one of those three. Cannot be here. Cannot be here. So I has to be one of those three. I in the dark region has to be one of these 5. Obviously cannot be here because one of these is I. One, two. G cannot be any of these, but G could be any of those three. The ending points also have to be different. That's one thing we should also keep in mind. Remaining digits of blue. No 2 or 4. So 1, 3, 5, 6, 7, 8, 9. We know 2 out of 5, 7, or 9 are here. One has to be from here, and it matches this one, so there. Oh. This digit in row 9 obviously can't be in the blue region. It's not the same as either of these two. So this has to be either this one or this one. Which means this 1, 2, 4, 8 has to be one of these digits here. Obviously, it cannot be 2 and 4 here. So this cannot be 3, 6 here. Because, again, this, of these digits, these 4, this digit is going to be one of these two, because it can't be 5, 7, or 9. So that means you can never have 3, 6 be here. So this is not 3 or 6. So this digit has to be 2 or 4 here. Because the reason why we know that is this is either 1, 2 or it's 4, 8. And this is 2 or 4. So that means we cannot have another 2 or 4 here somewhere in row 9 because this is 1, 2 or 4, 8. This is 2 or 4. That eliminates 2 or 4 here. So this is 1 or 8, which makes that 2 or 4, which is next to a 2 or 4 there. So the other 1 or 8, so we have a 1, 2, 4, 8 quadruplet in row 9. So that eliminates 1, 2, 4, 8 in the rest of the column. So this has to be a 3, 6 pair here, and then the other is 5, 7, or 9. That eliminates 3 and 6 in the rest of the blue region. This is a 2, 4 pair. That eliminates 2, 4 in the rest of the column. So we know one of these is going to be 3 or 6. That eliminates 3 and 6 in the rest of the column. So no 6 here. That was kind of cool. If this is 2 or 4, this has to be 7, 8, or 9. If this is 8, this is 1, 2, or 3 to be 5 away from that. So this digit must be the low digit from, sorry, the 2 or 4 from here. And then the other 1 or 8 has to be related to this. So one of these is 3, 6. We're not sure which. That was kind of interesting. Remaining digits of column 9 cannot have 2 or 4. And this cannot have 3 or 6, so the 3 or 6 has to be in the dark region. So we have guaranteed 1, 3, 5, 6, 7, 8, 9. That means in the rest of the dark region is no 3 or 6. So we have, these are 1, 2, 4, 5, 7, 8, 9. Obviously, 5 cannot be 5 away from another digit, because if you subtract 5 from 5, 5 or more from 5, you get 0 or less. If you add 5 or more to 5, you get 10 or more, none of which are digits. Okay. Um... Hmm. Whatever this digit is, whatever this digit is, cannot be here in the yellow region. It has to be one of these 3 digits, which means this digit cannot be this one. It has to be here. So that means this is 4. Clever. That makes us 2 and 1, so eliminates 1 in the rest of the region. 2 eliminates 2 and 1 here. Again, 4 cannot be here in the yellow region, so 4 has to be one of these 3, which means this can't be 2 or 4, it's 8. That means this can't, this is then 4. That eliminates 4 and 8 in the rest of the region. 8 is 5 or more away from 1, 2, or 3, so this cannot be H here, which means we have a guaranteed H in one of these 2 cells here. Okay. This is 1, 2, 3, 6, so the remaining digits cannot be 2 or 4. It's 5 with a guaranteed 8 here. 8 obviously cannot be here. We have a guaranteed 4 there. One cannot be here or here. It can't be here, so 1 is guaranteed to be here. That eliminates 1 in the rest of the dark region. So we have 3 and 6. Whatever that digit is has to be here. And the other 5, 7, or 9 here has to be here. Okay. um, so whichever digit's here has to be one of these 3 digits here for yellow. Okay. That doesn't really help us too much. Uh, what else do we have? So if this is low, this has to be high here, but it can only be 7, 8, and 9. If this could be 7, 8, and 9, so this could be 1 through 4. These 6 digits match these. That's not too helpful right now. These 3 digits specifically match these 3 here. But we don't know what that is. That's the problem. Where's 8 in the yellow region? 8 can't be here. 8 can't be here, so 8 in the yellow region is one of these 5. 1 cannot be here. So in the medium gray region, 1 is one of those 6. That's pretty broad. 1 is one of these 5. That's pretty broad. We have 8 guaranteed here, but 9 could be here. Um, so if this is high, this could only be 1 here. Because this high would be a 6. Otherwise, this could be any of the high digits. So B could be 1, 6, 7, 9. Oh, A cannot be any of these digits in the medium region. It has to be exactly the same as this. So this cannot be 1. This is the same exactly as that because this sees all of the other cells in the gray region. So these are the same. So this is A, this is A. A sees all of the pink cells in the region here because this is A. So this cell sees all of these. So that's A for the medium. Cannot be here or here because of this A, and can't be here because of this A. So this has to be A. So A is guaranteed to be 2 or 4. Interesting. So these are all A. A sees all of these digits here. A is one of the 2 or 4 here, so this cannot be 2 or 4. So these can't be A. Where is A in the light region? It has to be one of those 2. Where A obviously is one of these 2 in column 9. So this cannot be 1 here. 1 in the dark region then is one of these 5. Or sorry, the medium region is one of these 5. So this cannot be 1 here. This can't be 1 here. So we're guaranteed a 1 there. So we have A here, A here, A here. A is one of those 2. So no A here, no A here. None of these can be A. So A in the orange region is one of these 4. Okay. A can't be here. A in the yellow region is one of these 6. A in the green region is one of these. Cannot be here because it can't be 2 or 4 here. So it's one of these 4. So where is A in column 2? Can't be here because of the pink region. Can't be here because of this A. Can't be here because it's not 2 or 4, so A has to be one of these 4. So this cannot be A here. So we're guaranteed one of those 4 is A. And it could obviously be the 4 still, right? The other 2 4 in the pink region must be there. But that doesn't really tell us much. It actually has to be one of these 2. The other 2 are 4 in row 2. Can't be anywhere in the pink region. Can't be here because of the 2, 4 guaranteed in the column. Can't be in part of the pink region except for here, I should say. Cannot be here because of the 2, 4 in the column. So either this is 2 or 4, or this is 2 or the other 2 or 4 in row 2, which means the rest of that, the cells that see that cannot be 2 or 4. Because we have an A here, which is a 2 or 4, and one of these 2 is a 2 or 4. This cell sees both. So this can't be 2 or 4 here, which means this can't be 1 correspondingly or 8. Interesting. The interesting aspect here is if this is a 3-6 pair, that means that eliminates 3 and 6 in the rest of the gray, medium gray regions. So these can't be 3 or 6. This can't be 3 or 6. This would have to be a 3-6 pair, which does work because they are opposite parities. One's odd and one is even. Because we are guaranteed, again, 3 and 6 have to be one of these cells here. 1 has to be one of these cells here. Oh. No, we don't have any of that. Oh, A cannot be the same as F because they have to start on different digits. So this cannot be A. Therefore, we know A is here. So A cannot be here. Where is A in the green region? It must be one of these two. So this cannot be A there. That means A can't be here. So we have A guaranteed here, A guaranteed here, or A guaranteed in one of these four. Okay. This can't be A. So A could be one here, or this. So A in column 1 is one of these three. Okay. A cannot be where E is because those are different digits. So A is one of these three, A is one of these three, A is one of these three here. A could be either here or here as the 4 or 2. And A could be one of these two. So this is guaranteed to be A, so it's 2 or 4, which means this digit must be 5 or more away from it, so it's 7, 8, or 9. We don't know about these. Neither of these could be A. That could work. Yeah. Hmm. So one out of the other 2 or 4s has to be one of those. So the B has to be one of these three. Oh, this is 2 or 4, which means this cannot be 1, 2, 3, or 4. It has to be 5 or more away from it, so that's 7, 8, or 9 also. So we have 1 be one of those 4. If this is the other 2 or 4, then this has to be 3, 6. That's interesting. If this is 3, 6, then this can never be 3, 6, so therefore you'd have to have 3, 6 here. But this could be the other B here, right? And it would have to be here as B. We do know, okay, so B has to be, where is B in row 1? Cannot be here because it can't be 2 or 4. Can't be here because it can't be 2 or 4. Can't be here. So B is definitely going to have to be one of these digits here, which means this can never be B. So this can't be 2 or 4. Where's the other 2 or 4 in row 2? It has to be here. So this is a 2-4 pair. This cannot be 2-4. That eliminates 2-4 in the rest of the column. So this is B here. This cannot be B here. B has to be one of those three. So there's no B here. B could be here or it could be here. We don't know. B is definitely one of these three, but we don't know which. That means B has to be one of these four, because there's no other place for it. So this cannot have 2 and 4 here. So we could have 1, 3, 5, 6, 7, 8, 9 as possibilities. Sorry, we shouldn't be using B. Let's make this Z. Because B specifically is where the rat B is, and obviously that's not a 2 or 4. So A and Z are in a 1 to are 2 and 4. So that means A and Z are here. A is over here, Z could be here, or one of these two. So Z has to be one of these 3 cells in column 8. In column 7, it's one of those 4. Cannot be any of these. It's here in column 6. Where is Z in row 3? Cannot be here. Because this can't be 2, 4. This can't be 2 or 4. So Z has to be one of these 4 there. Okay. In row 4, it's one of these 4. Hmm. A and we don't have any information. Obviously, this can't be 1. Oops. Not 1. Z obviously cannot be here because it's not 2 or 4. So Z is either here or it's one of those 2. All the last digits are different too. Okay. Just something I have to keep in mind. It's going to be not easy to notice which one's which. I mean, we have 3 last digits here. We have a last digit here, 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 and this and this. And then here. Oh, we have 3 last digits that are 5, 7, 8, and 9. Interesting. Um, Do we have another? We have one that's potentially 2, 4, 5, 7, 8, 9. Oh, we have 4 last digits, which are 5, 7, 8, and 9. That eliminates 5, 7, 8, and 9 as the last digit at all for any remaining digits, right? This is definitely 5, 7. This is 7, 8, or 9. This is 5, 7, 9. This is 5, 7, 8, 9. We have 4, 5, 7, 8, or 9s here. Therefore, this cannot be 5, 7, 8, or 9, and it must be Z. Then, because it's the other 2 are 4. That eliminates 2 and 4 in the dark regions. So this is Z, which means Z cannot be here in the dark region. Z is one of those 2. Z is here for dark. So this cannot be Z. This can't be Z. Where is Z then in column 8? It has to be one of these digits here, which is an even digit. So then we cannot have this be 3, 6, because if this is 3, 6 as a pair, that would eliminate 3 and 6 here. But where would the 3 and 6 be in the rest of column 8? They both have to be there, but also Z has to be there. So this cannot be 3, 6, which means this is Z here, as the other 2 are 4. And 1 out of 3 or 6 is here, the other 3 or 6 is here. Because we need 1, 3, 6 to be here. It cannot be any of these. It can't... Oh, it could be both of these. No. One of them has to definitely be here because we don't have any other place for the 3, 6 in row 1. The other one could be here. We don't know. So remaining digits cannot be Z, cannot be 5, 7, 8, and 9. So we have in the remaining digits for the last digit. So no more 8 here. H can't be here either. And the reason why is because of this grape. That grape forces us to be 7, 8, or 9. So where is the other 3 or 6 in? So we have to have one of these could be 3 or 6. But the other 3 or 6 has to be one of these. Which means we can't have both 3 or 6s here. Where's the other 3 or 6 in row 1? It has to be here. So this is the other 3 or 6. And specifically, Z is even. So Z has to be with an odd digit. So 6 can't be here. Therefore, 3 has to be here, which means this can't be 3. 6 has to be here, which means 3 has to be one of these 2. Which means this can't be 3, that's 6. That eliminates 6 in the rest of the dark region. 6 is one of these 2. This has to be Z, no H. Z and 3. So this is 3 with 2 or 4. Obviously, this can't be 4, so we have a 1, 2, 3 triplet in row 8, which eliminates 1, 2, 3 in the rest of the row. So that just leaves 5 through 9 here. That means the remaining digits in the yellow region are 1 through 4. That's interesting. That 1 through 4 eliminates 1 through 4 in the rest of the column, so no 1 there, no 1 there. So the remaining digits in column 2 are 5, 6, 7, or 9. That's interesting. This is 6, 7, or 9 here, so this cannot be 6 here to be 5 apart from it. Z is one of these 2. Oh, no, still one of these 3. Well, we know A and Z are both here. So this can't be Z here. So Z is one of these 3. Z is one of these 3. Z is here. So Z cannot be here. So we're guaranteed a 3 here, which means the rest of orange cannot have a 3. And Z is guaranteed here, so this can't, and A is guaranteed in all of these columns here. So this can't be 2 or 4. So this has to be 1, 5, 6, 7, 8, 9. And we know A is one of these 3. A is one of those 2. Okay. One of these obviously is a 6. We don't know which. So since this can't be 6 here, this can't be 3. Z is here. So these are different 1-8 pairs here. A, this is in a 1-2 ratio with A. This is in a 1-2 ratio with Z. Yeah, these can't be 1. We already knew that. So again, this has to be 6 there. It's 5, 6, 7, 8, 9 as a quintuplet. Ends. Oh, this can't be 5, 7, 8, or 9 because we have a 5, 7, 8, 9 quadruplet here. Therefore, this is 6. That eliminates 6 in the rest of the row. That means this can't be 6 here. No 6 there. Where's the 3 in column 7? It has to be here. That eliminates 3 in the rest of the row. So one of these is a 6. So we have a 6 as an end. So no 5 through 9 as an end, which means the ends can only be 1 through 4. So this can only be 1 through 4. This can only be 1 through 4. It cannot be 2 or 4 because of the 2-4 pair in the medium gray region. And this can't be 2 or 4 because Z and... Oh, it could be 2 or 4. We have 6. That's Z. A has to be some ending of a path. So this has to be A here. Because this can't be A. This can't be A. We have Z being here. So then this is A, guaranteed. So A cannot be here. So this is 7, 8, or 9 also. And we know then that A cannot be 4, because that would force both of these to be 9, to be 5 away from it, and they are in the same region. So A has to be a 2. So this is not A here. A cannot be here. A has to be here, here. So no A here. A has to be here or here. But we know A is a 2. This can't be 2 here because we have a 2. We have the 2-4 pair as an ending. And A eliminates A from being there. This A eliminates A from being there. Everything else is 5, 6, 7, 8, 9. Here. So A has to be a 2. Because it's in a 1 to 2, it's 5 away from 2 unique digits. Because these must be unique because they're in the same region. And 4 cannot be that. So A has to be a 2. A is a 2, which means Z has to be 4. So this can't be Z anymore. So Z is one of those 2. So these can't be 2. It's 1, 3, 4 is a triplet. 2 is 5 away from 6 away from 8. 2 and 1 are in a 1 to 2 ratio, so this can't be 1. That's 3, which makes that 6. 2 eliminates 2 here, so that's 3. Z is a 4. This is a 4. 2 is in a 1 to 2 ratio with 1. That leaves us as 4 and 8. That leaves us as a 1, 3 pair. 3 already is the ending digit here, so this must be 1, which makes that 3 there. That means this can't be 3 there. It's 6 and 3. That eliminates 6 in the rest of the column. 2 eliminates 2 there, so this is 4. 8 eliminates 8 in the rest of the region. 8 also cannot be here. It cannot be here because of 8 in the column. So where is 8 as an ending digit? It has to be here. So that's 8, which eliminates H there. So H is one of these two. 8 eliminates 8 being here. Where is 8 in the column 9? It has to be one of these 4, so this cannot be 8 anymore. 1 eliminates 1 in the rest of the pink region, and eliminates 1 from being here. Where is 1 in the light region? It has to be F. So F is 1 here. That eliminates 1 being there. This can't be 1. Remaining digits of the light region, Z, which is 4. So 4 has to be one of those. 4 has to be one of those. 1 eliminates 1 from being there, so this is 3 or 4. 3 is G, so this cannot be 3, it's 4. That eliminates 4 from the rest of the yellow region. So no more 4 here because of 4 in the column. Where is 3 in the light region? Can't be here because of 3 is in the column, so 3 has to be there. That eliminates 3 there. I could be 6, or it could be 5, 7. I can still be 6. Where is 8? 8 as a rat cannot be D. We already have 2, 3, 4 accounted for, and 1. 1, 2, 3, 4 accounted for. C could be 8. D cannot, because we have an 8 in the column. I cannot, because we have 8 in the region, or in the row. So can't H. So C has to be an 8, which eliminates 8 in the rest of the region. We have a 5, 7, 9 triplet in row 2, which eliminates 5, 7, 9 in the rest of the row. So this can't be 5, 7, or 9. It's 8. That eliminates 8 from being here. A, B. So A is 2. B we don't know. C is 8. D is 5, 6, 7, 9. So, yeah, we have H, I, D, and B left. Okay. This is 5, 7, 9 as a triplet. That eliminates 5, 7, 9 here. It cannot be 8. It's 1. That means no more 1s in the dark region. These two cells must be the same as these. 3 eliminates 3. Oh, okay. So 3 is 5 or more away from 9 only, out of 6, 7, or 9. So this is 9. That eliminates 9 here. It's a 5, 7 pair. That eliminates 5 and 7 in the rest of the column. So no 5, 7, or 9 there. It's 6. 5, 7 eliminates 5, 7 in the rest of the pink region. So that's 9. So no 1 or 9 here. No 9 here. No 9 in the starting digits, so this can't be 9. We have 5, 6, and 7 remaining. 9 eliminates 9 in the rest of the green region, so this is not 9, it's 7. This can't be 7 or 9, it's 8. No 7 or 8 here. Whoops. No 7 or 8 here, no 7 or 8 here, no 7 there. 7 eliminates 7 from D. So one of H or I must be 7. That eliminates 7 in the rest of the row, so this can't be 7 there. It's 5 or 9. No 7 or 9 here. 8 eliminates 8 here, so that's 5. That eliminates 5 in the rest of the region and row, so D must be 6. No more 6 here. This becomes a 5-7 pair, which eliminates 5 and 7 in the rest of the row, so this can't be 5 or 7, it's 9. This can't be 5 or 9, it's 6. That eliminates 6 there. So no more 9. This is guaranteed then to be I. H is there. 9 is one of those. We don't know which. 6 eliminates 6 from there. The 7-9 pair eliminates 7 and 9 in the rest of the region. So this can't be 7 or 9. It's 8. This can't be 7 or 9. It's 3. And row. So that leaves that as a 5. 5 eliminates 5 there. So it's 9. This can't be 5 or 9. It's 1. That leaves the remaining digit in column 6 as a 3. That eliminates 3 there. So it's 1 and 3. 1 eliminates 1 here. And 1 here. The remaining digits in the orange region is 5 through 9. This can't be 9 because of 9 in the column. This can't be 9 because of 9 in the row. No more 8s here because of 8 in the column. We have a 5-7 pair remaining in column 4, which eliminates 5 and 7 in the rest of the column. No 5 or 7 here, it's 9. This must be a 1-4 pair remaining in row 4. 1 eliminates 1 here, so that's 4 and 1. That means this can't be 4. Where's the 4 in the light region? It must be here. And this must be I here. 9 eliminates 9 in the rest of the row. We have a 7-9 pair in column 7. And an 8, which eliminates 7 and 8 in the rest of the column. So this must be 5. That eliminates 5 in the rest of the region and row. 9 eliminates 9 here, so it's 7. 7 eliminates 7 in the rest of the blue region, so this is 5. That's 9. So I has to be 5, so that's 5. This is 7. 5 eliminates 5 here. This becomes a 7-9 pair, which eliminates 7-9 in the rest of the region, so this can't be 7 or 9. It's 5. No 5 there. 7 eliminates 7 here, so that's 5. No 5 here. We have a 7-9 pair in row 1. This can't be 7, so that's 5, which makes this 7. No 7 or 9 here. It's 5, which means this can't be 5 there. Okay. 7 eliminates 7 in the rest of the row here. It's 6-8 as a pair. That eliminates 6-8 in the rest of the region, so this can't be 6 or 8. That's 7, which makes that not 7, so that's 8 and 7. That eliminates 8 there, so it's 6 and 8. And the last remaining digits have to be different. And this is 7, so this must be 9 there, which makes that 7 there, which makes that 9. And that's 7, and this is a 6. And 9 eliminates 9 there, so it's 7 and 9. Whew. Preliminary phase complete. June 5th, 1974. Or it could be actually May 6th. I don't know. I'm not sure if this is European date. It could be it's probably actually May 6th, would be my guess. I don't know. I'm not sure if this is American date standard or European or international, I think it is. Anyways, all 9 remaining rats performed magnificently, but one rat went above and beyond, displaying innate flair and understanding of numbers by visiting the digits 1 through 9 in perfect numerical order. Oh, interesting. Yeah, F did. 1, 2, 3, 4, 5, 6, 7, 8, 9. I had a feeling there was something special about Finks, and I must admit I'm delighted at this result. She will begin tackling the mazes next month, starting with Primer, once the designs for Phase 1 are complete and Elliot has fully tested the technology. I can't wait to fully explore what Finks is capable of, and more than anything, I am excited to be working more closely with my friend. But who's the friend? Is it Finks or Elliot? Anyways, pretty cool actually. This was a very different chaos construction type, which I'm not used to, but once I got the hang of it, it kind of made sense. The actual difficulty part was trying to figure out what digits were where, because I'm not the best at even though I've done a lot of chaos construction, I'm not the best at irregular region Sudoku. I don't know why, but I can't necessarily spot out some obvious things like this A had to be these digits here, right? I didn't spot that out until pretty late. So, but it was some nice interactions with where each digit had to be, with the starting and the ending spots disambiguating the puzzle. Yeah, just overall very well developed puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.